Okay, so the last couple of days I've been really trying to hammer into your head some of the things you need to learn. This unit's very repetitive. We usually start off with kind of an intro to a topic. Then we're going to talk about what the graph looks like. And so we've done that twice now. We've talked about what polynomial graphs look like. So quick recap on that. Here's some polynomial graphs. That guy's linear. This one's quadratic. This one's cubic, etc. You should hopefully know a few of those. The last couple of days, we've been focusing on exponential graphs. Here is an exponential graph that is growing. We'd call that a growth, increasing graph. We can also have graphs that decay or decrease. Most of the time, exponential graphs don't include the whole bottom half of the graph. Like all of the y negative numbers, usually those don't exist because this thing has an asymptote at about 0. Now it doesn't have to. We actually did a graph yesterday where I believe it looked something like this. The graph started down here before going up, and it's because the graph had like a y equals 2 to the power of x, and then there was like a -7 way afterwards. And that kind of pulled the whole graph down. So that's what we've done so far, talking about how to graph these things. Today's topic is one that's going to come up, though, with all of these as well. We have to be able to solve equations. Now, we've already done this a little bit in this course. I've already shown you how to solve polynomial equations because you should know how to solve something that's linear because you all took grade 9 algebra. I don't mean to be insulting here, but you already know how to do this. This is a linear equation. Why is it linear? Well, the x is to the power of 1. That's why it's linear, right? Could you guys solve this sort of thing right here?
Yes.
I sincerely hope so, but let's just practice it anyways. -9 from both sides. -6 equals 6x. Divided by 6. Ta-da! X is -1. Does that make sense? You've already learned how to do that at some point in your life. Okay. These would be a linear and another linear, but like you can solve that stuff, right? We've also talked about how to solve quadratic stuff. For example, if I give you x squared plus 5x plus 6 equals 0, hopefully you remember how to solve this.
Yeah.
How do you solve it? That'll work. Or you can factor. So you could do like, say, x plus 2 and x plus 3 equals 0. How did I come up with the 2 and 3? Where did I pull that from? Add to get 5 times to get 6. This means that x would be -2 and -3. So you've already learned how to solve linear and quadratics. We don't cover cubics, quartics, and solving those things in Dash 2. They do it in Dash 1, but not in Dash 2. So you have to be able to solve anything that's linear, which is really just grade 9 algebra. You have to be able to solve anything that's quadratic, which, when do you guys go to the door, by the way? Quadratic might mean use the quadratic formula. I've said this before. They put the quadratic formula on your data sheets. My guess is that's because they expect you to use it. Okay. We've also talked about how to solve rationals. This was our first unit. If I gave you x plus 2 over x plus 3 equals x over x plus 4, you need to be able to solve something with a fraction in it. I don't want to take the time and redo our whole algebra unit again, but hopefully you recall doing this.
Yes.
Today then, today's goal is to focus on how to solve some things that have exponents in them. Here's the reason why. It's often much more difficult to try to solve exponential equations because the variable is the exponent. That's what makes these challenging. Let me show you an example once I find a new slider. There we go. This is your next one below, right?
Yep.
Yeah, okay. So this is something they might ask you to solve. Try to tell me what x is when 128 equals 2 to the power of x minus 1. Now here's the issue with all of the algebra you've learned before. You want to get x by itself, right? That's usually what we try to do. How in the world do you get x by itself when x is sitting up top here? And you already know how to do this. Can you say that louder?
Same basis.
Yeah, what we do is we use a technique called like bases, or same bases is essentially the same thing, where we try to find a way to make it so that this base right here is 2. Okay. We're going to try to find a way to make 128 also have a base of 2. Does anybody know how many times you can times, like how many 2's go into the number 128? Let's square root it.
64.
Like 128, let's do this. Divide by 2 gives you 64. Divide by 2 gives you 32. Divide by 2 gives you 16. Divide by 2 gives you 8. Divide that by 2 gives you 4. And divide that by 2 gives you 2. So back to my original question. How many times does 2 go into 128? 7 times. 1, 2. Well, we don't divide by 7. I'll get to that in a second, though. But 3, 4, 5, 6, 7. This means that 128 is equal to 2 times by itself 7 times. So it's better to write it as this, 2 to the 7. Does that make sense? Once you figure out that twist, then this is kind of a novel idea. Let me just go below here. Rather than writing it as 128, write 128 as 2 to the power of 7. And that equals 2 to the power of x minus 1. Now this is where this is brilliant. This is a base of 2. On the other side, you also have a base of 2. They cancel. What are we left with? Well, you're left with 7 equals x minus 1. And I was just kind of making light of this a few minutes ago. This is now linear. So pull back out your grade 9 algebra skills, add 1 to both sides. X is 8. Ta-da! Which is kind of brilliant in a way, isn't it? It's a clever way of being able to solve exponential functions. You have to, at its core, take the number that does not have an exponent and find a way to make it so that it does have an exponent. And more than just that, it has to have an exponent such that the bottom number is like 2 to the 7. This bottom number of 2 is the same as that bottom number of 2, so that it can cancel.
That's really sneaky.
Isn't that sneaky? Yeah. So this is the skill I want to work on for today. So now it may involve a little more work once in a while. Let's try this one here. This is 2 bracket 4 to the power of 2x equals 1 over 32. So I'm going to play a couple of little tricks here in order to try to get us to the point where we can cancel those exponents. Or, sorry, cancel the bases. The first one involves this 32 right here. 32 on the bottom of a fraction can be written in a slightly different way. What happens when you have 1 over something? How does that work with exponents? You guys remember? That's right. It's the power of negative 1. If you don't remember that rule, 1 over 2 is the same thing as 2 to the negative 1. So 1 over 32 would be equal to 32 to the negative 1. Makes sense? So 2 bracket 4 to the 2x is going to equal 32 to the negative 1. Well, we're not quite to the spot where this is useful yet. Because does this 32 have the ability to cancel the 2 and the 4? Well, not unless they're exactly the same as each other. And so, although that's a nifty trick, that actually wasn't useful yet. So I kind of did that just to waste your time. But I wanted to make a point. Okay. One of the other problems we have here is that this 2 sitting right here, can I times that 2 by that 4? The answer is no. This 2 you get 1 of. This 4 right here, we don't know how many of them we get. So you can never put those two numbers together and make it an 8. It becomes a bit of an issue. What sometimes is better is to take this 2 and divide the 2 off of both sides. So like divide this side by 2. I'm going to clean this up. This is kind of ugly looking here. Bear with me for a second. I'm going to divide this side by 2. And then it means I have to divide this side by 2 as well. See how that kind of gets rid of the 2 right there? I can't have that 2 sitting out front. That's a bit of a problem for me. Now I have 4 to the 2x. What happens when I take the 32 on the bottom and combine the 2? It's 64. Yeah. Well, you know how I just kind of showed you that one trick where you can make it to the -1? You can still do that. But now is a bit more of an effective time for it because now it's 4 to the 2x. equals 64 to the minus 1. You know how we used to have that 2 sitting out front? Now we don't. We have a 4 right here and a 64 right here. Now the question is, how many 4s make up a 64? No, not 2. It's not divided by 4. It's like 64 divided by 4 gives you what, 16?
Yeah.
And then 16 divided by 4 gives you 4. So I have 1, 2, 3 4s there. That makes sense? So here's how I write this then. 4 to the 2x equals 64 is actually 4 to the 3. And there's a little minus 1. Because, right, that minus 1 is still sticking around there. So that's why I'm going to kind of put this in just like a bracket there to make sure it's kind of separate. This is why we did a review of exponent rules. What happens when you have a 3 and a minus 1 here? Do you add them together or multiply them together? You multiply, yeah. So I could then say that I have 4 to the 2x equals 4 to the minus 3. Now the 4's cancel, yeah. Cancel those 4's. And now you're left with a nice linear 2x equals minus 3. Divide by 2. Bob's your uncle. We're done.
Bob's your uncle.
Is he? Not your uncle? So this is more of an algebra sort of thing. To be honest, it might have fit better if I threw it back in the algebra unit. But I don't think we would have been ready to do this sort of thing back in the algebra unit. I think it's probably better to do it at this point here because we're kind of working with exponents anyways. I want to show you another nifty trick. Let's say that this just isn't happening and you were looked at that and it just kind of over your head kind of thing. There is actually another way we can solve this. You need your graphing calculators though. What we could do is go to our y equals screen and clear everything out. And for y1, we're going to type in the first half of the equation, which would be 2, then a bracket, then a 4, close the bracket, all to the power of, and then because my calculator doesn't do the little like shift up thing, I'm going to put this exponent of 2x, I'm going to put it in brackets. And then for the second y, I'm going to put in 1 over 32. And we're going to graph this. 1 over 32. Now, here's the one issue with graphing. You do have to have a little bit of knowledge of what these graphs are going to look like before you start graphing, because there's a good chance that these graphs are not going to show up very nicely for you. So, I mean, I'll press Zoom 6 and graph it, but I have to kind of know what to expect. Hello. No. Okay. Okay, so this is what I have showing up on my calculator when I graph the two things. Maybe the first problem is, hang on, didn't you graph two things, Chris? Where's the second one? So let's talk through these. Well, unless you have Devin's calculator, yeah. So here's the first one. This looks like it's an exponential graph that is taking off very fast, which I think makes sense. There's a base of 4 right here. That means the graph should be shooting upwards, quadrupling every time. And this 2 in front should be my x-intercept of 2 right there. So that kind of explains things. But that 1 over 32 is essentially like 0 point something really small, right? Why do I not see that graph? Because it's literally like right on top of the x-axis right here. So that's one option. You could go over here to y equals, and you can make the line like a thicker line. Or here's another option. Take a leap of faith. They're going to cross at some point, I believe. So I'm going to kind of put the cursor over in this general vicinity here and just press yes to the first curve, yes to the second curve, yes to the guess, and just take a leap of faith that my calculator will find a way to find where they cross. And see whether yours does what mine does. Okay, I'll come take a look.
Nice.
No intercept. And then there's the first graph, there's the second graph, somewhere in that vicinity. Okay, so it's over there. That's okay. Did anybody else get what I got there? Negative 1.5 for x.
I did.
You got that, or you didn't?
I did.
You did.
I didn't.
You didn't. Okay.
Uh-oh. Watch out.
Intersection 3.
Okay, why is this doing?
Because this was supposed to be to the 2x.
Oh, that's fine.
Try it again.
As long as you answer
Okay. So basically what I did is I took this first half of the equation right here. It went into y1.
Yeah.
I took the second half of the equation, went into y2.
Yeah.
I can't actually see the 1 over 32 because it's essentially like right along the axis line.
Okay.
So I just went second calculate the intersect, and I wanted to see where they crossed. And I took a leap of faith that somewhere in there they cross. And in doing so, I got negative 1.5 for x.
Do I have to put the exponent in a bracket?
Yeah, when you do this, it's probably best to do to the power of bracket 2x.
Wait, so if you do that, it just skips the whole, you skip the whole process.
What?
Say that again.
I think I've got it.
Like, what you could do is you could do it using this algebra process I just showed you there.
Yeah.
But what I've also shown you now is that, let's say that's not happening for you. You can do it on your calculator too. So if you feel comfortable on your calculator, it's actually an excellent tool. A lot of students will try to rely on that. In my Dash 1 class, I really encourage my students not to use the calculator too much. But for you guys, it's probably not that big of a deal. Like, you should know a little bit about how to do like bases, but finding where these graphs intersect and cross each other is a really clever way of solving them. Because look, here I got negative 3 over 2. That's negative 1.5. Here I got...
It's magical.
I'm going to do that.
Here I got negative 1.5. So, unless you have to show some work, which you don't have to on a diploma, right? It's either A, B, C, D, right? Then both are valid ways. So, that's my job. I need to show you different ways of solving. So,
Wait, is that easy? It's just to put it in your calculator.
sometimes it is. Sometimes it's the easiest way.
So you can do it for all of them, right?
You could. I would like you guys to do a little practice on both so that you have skills on both. But yeah, if you're stumped, it's a great method. Okay, so why don't we try this next one here? I mean, as you guys look through my notes, most of it's just examples, right? So let's try another example where I'll do it with you, and then I'll have you guys try a few. But let's try first doing it by doing like the algebraic type of method. And then after that, let's just check in our calculators and try doing it both ways. So, do you guys remember the trick for what a square root means?
No.
It's 1/2. If you have the square root of x, it is x to the 1/2.
So it's also 25 to 5.
So there we go. That's the first thing we can do is we can say that this is 125 to the power of a half.
Wow.
Okay, well, we're fairly close to the point where we want like bases. How many times do you think 5 goes into 125? Well, 125 divided by 5
3.
is 25. And then if you divide that by 5, it's 5. So there are 1, 2, 3 5s in 125. Maybe you guys remember doing like factor trees like this where you'd say like 125 is 25 and 5, and then 25 is 5 and 5. So you could say that 125, shouldn't write it like that, no? Is 5 to the 3. Here's one of the first twists, though, is that there's still that 1/2 still sitting there.
So then it would be 1.5.
That'll work, yeah. So 5 to the x plus 2. How did you get 1.5 out of that?
Times 3.
Yeah, the rule here is you times them. So 1/2 of 3 is 1.5. Last step, cancel out the 5s. So x plus 2 equals 1.5. Minus 2 minus 2. Minus 1/2. Truth be told, common base method that I'm showing you here algebraically is actually not really that much work sometimes. Sometimes I actually think the more work is actually the graphing calculator one. But I'll leave that to you, like potato, potato. So let's try it the other way. Go to your y equals, clear everything out, and then type in 5 to the power of, and then if you have an old school calculator like me, you need to do brackets here. Bracket x plus 2 to make sure your calculator knows that all of the x plus 2 is the exponent part. And then in the next line, find me the square root of 125.
Oh, you don't go 125 to the power of 1.
Well, you can go 125 to the power of a half, but let's just type it in as the square root of 125. Okay, so let's graph the thing. That looks like it's my exponential graph. Where's the square root of 125 graph?
It's probably on the axis.
What is the square root of 125?
Or
It's
like
not-
way
I changed
somewhere
it
else.
to like the bigger one.
It's 11.18.
It doesn't exist.
Well, not that it doesn't exist, but my window currently goes as high as 10. This is the sort of thing, by the way, guys, where you need to make sure you find a way to troubleshoot. Because you can't just say it doesn't exist, it might be here. Like, there is a solution to this. You just need to spend a few minutes trying to try some buttons on your calculator. See, well, let's make the graph taller. Let's make it lower. Let's,
Found it.
Exactly.
Mine did
So I'm going to make my y go as high as maybe 20 now. And so now when I've got this exponential graph taking off, there's the other line I'm looking for.
Mine gave mine.
Second, calculate the intersect, and then put the cursor essentially where it looks like they cross.
Mine worked without even moving it.
Yeah, since it only crosses once, you probably don't need to put the cursor all that close. The reason why you have to do this whole first curve, second curve guess thing is that you might have more than 2 graphs on your graph at the same time, and it might cross like 3 or 4 times. So it'll find the closest one then if it crosses like say 5 times.
Okay, so if you only have like the two.
If you only have the 2, then just like press enter, 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 and you're good to go.
Alright.
Since it only crosses once, yeah, it's the only one is the closest one. So that's essentially my lesson. I mean, that's the new information. So I don't know whether you guys want to try a few more as a group, or whether you want to try. Do you guys want to try this one by yourself or do it as a group?
Yes, we do.
Boy, we're very opposed here. Okay, how about one more as a group, and then you have to go by yourself, Keelan. Okay, so this one's actually probably easier than the first 2 I gave you.
Yeah.
Do you have to do any sort of like pre-rearranging work? I'd say not really. You just got to take that 9 and figure out how do you make a 9 a base of 3. Well, isn't 9 3 squared? So 3 squared next to x minus 1 equals 3 with x minus 3.
Would you just kind of like be 2x minus 2?
Exactly, because these things have to multiply by each other, so you have to FOIL them. So it's actually 3 to the 2x minus 2, because you have to times. Great news. 3's are common basis. We can cancel the 3's. So you're left with 2x minus 2 equals x minus 3. I got negative 1. The algebraic method is really not probably that bad. But again, you might have a choice. So let's try it the other way. For this graph here, you're going to want to go 9 to the power of, in a bracket, x minus 1. And for the other graph, 3 to the power of, again, in a bracket, x minus 3. Okay, before I press graph, I just want to talk about what this should look like. One of these is an exponential graph growing at the rate of 3 times. The other one is an exponential graph growing at the rate of 9 times. That one's probably taking off just like a... So I should know what to expect before we start. Oops, I screwed up my calculator. There's one graph. There's the other graph. They cross somewhere. Since they only cross once, probably, if you just press intersect and just press enter 3 times, it'll find where they cross. And lo and behold, it crosses a minus 1. Quick thought here. Does that y value matter to us? No. Because what are we solving for?
X.
X, yeah.
Hey, you got minus 1.
Yeah, I forgot that one.
Put it right there. Okay, this one's yours. Try this one then. See if you can get this one by yourself. if you haven't already tried it. Yeah, you have to make the common base 2 as opposed to 4 or 8. What you have to do is you have to make this 2 to the 3 and that one 2 to the 4. We'll do that one probably as a group.
It's pinky.
What did you get? What did you get?
I don't really want to see you. 3x minus. Do you want to see? No. So I just left it.
Okay.
Yeah. So let's try and see what it
I
does.
would not.
X is 1. Let's try it on the break. See if you can try it on the break. Then you can.
Thomas, I'm sorry.
That's why you have 2 different ways.
No, honestly, it's way
Right on the middle.
I haven't been wrong yet.
Really?
Alright, so I just looked at Cole's. Cole graphed these things, and I mean, we just took a leap of faith. It said that x equals 1. But I mean, do we really trust Cole's calculator?
No. No.
Tate does.
I do, 'cause I got the same one.
Here's one of the issues with the calculator. You don't really have much ability to check your work. Does that make sense? Like, you're kind of taking a leap of faith and saying, I know how my calculator is supposed to function, and hopefully I'm doing it properly. But there's not a lot of recourse for checking. So let's try it algebraically as well. And by the way, here's one more reason to do it algebraically. Although the diploma cannot test your ability to do written work, I've already shown you they have the ability to show you somebody else's work, and then they ask you, where did they make the mistake? Have we talked about this sort of thing before?
Yeah.
Where they'd say, like, step 1, step 2, step 3, step 4, and then you have to figure out where the mistake is. So please don't just do this on your calculator. Although that's an excellent tool, you might be shortchanging your ability to solve, like, one of the doing the work questions. So I would say start here with a 64 then. How many 4s go into a 64?
3.
Yeah, 3. So you have is 4 to the x plus 5 is 4 to the 3 times by a 2x. This 3 times is by that 2 to give you a 6x. Cancel out the 4s. So you have x plus 5 equals 6x. 5 equals 5x. Divide by 5. X is 1. Cole's right.
Yeah.
2 different ways. Both valid. But please don't just do the finding where they cross method. You're limiting yourself. Especially, I mean, I'm going to give you questions where I say, here's somebody's work, find the mistake. So. Okay, I want to talk about this one for a second here. Let's say that you wanted to solve this one algebraically. You didn't just want to find where the two graphs crossed, because you want to challenge yourself. You understand that it's good for you to practice algebra. So you don't just want to cheat and say, hey, here's a couple of graphs, they cross right here. X is whatever it is, right? You want to try it algebraically. And this one here's got a bit of an issue because 16 and 8, you can't make 8 squared equal 16 because 8 squared is actually 64. So sometimes you may have to do a common base that's different than both of these bases. And the answer to this one would be, this is 2 to the 3. 2 times 2 times 2 is 8. And 16 is 2 to the 4. So rather than making the base this one of the two numbers, you may actually have to drop the base down to something even lower. So this is 2 to the 3 with a 3x minus 2. This is a 2 to the 4 with an x plus 1. Does that make sense how I had to not make the base either 8 or 16 or even 4? I had to drop it all the way down to 2 to make it work. So, and then what you have here is 9x minus 6 and 4x plus 4. Can I point out a really common mistake? And I bet you that when I make my test for Thursday, by the way, test Thursday. Everybody know this? Test Thursday. You've been told again. Okay. A common mistake might be to take the 4 and times by the 4x. but maybe I'd make it 4x plus 1. Because then you take the 4 and you forget to times it by the 1 here, so you might forget about that part. So don't forget you got to FOIL the 4 into the 4x and into the 1. So make sure this is a 4. And like the 3 times 3 is 9. 3 times 2, though, is 6. Don't miss that. Well, then cancel the 2's. So 9x minus 6. 4x plus 4. I got 2. You said you got 2 as well? Awesome. It's the sort of thing that you probably should practice a little bit. I'm not saying you need to spend 5 hours on it, but 5 questions? Given a duotang that I gave you yesterday and had a nice long chat about?
Yeah.
I don't think 5 questions is unreasonable, is it? For Friday? No?
Just 5?
Just 5. I'm not saying you need to practice this 100 times, but 5 times wouldn't hurt, okay? 5 in total by Friday. 5. 5 of the graphing ones on the first page, and 5 of the exponential ones on the next page.
Just 5? Wow.
But guys, here's the problem. I've still only got 4 journals in. I'm not asking for that much. People don't even do 5. Okay, I want to do one more example with you. Here's a good example where you cannot do this by hand. It is actually, there are some questions that you can't do by hand. Now, there is a way of doing it if you take some -1 math, but we don't actually solve during that method. The reason why this one's not solvable, there is a 5 right here and a 3 right here. 5 and 3 don't have a common base. So sometimes you have to use your graphing calculator. So like, take your 2 graphs and find where the 2 graphs end up crossing. So let's just do that one more time. 3 to the power of bracket, don't miss that bracket, x minus 5. 2, new bracket, 5, close bracket, power of new bracket, x divided by 4. So there's one exponential graph. Here's the other exponential graph.
I don't think this one's possible.
I know the answer for it.
I just kind of took a leap of faith and just said, gotta cross somewhere.
Walking on water.
I do not.
I tried.
If you run really fast.
I tried that. I'm not even joking.
Yeah.
Anybody else get that? 885?
I don't know what I did. Oh my god. All 5.
I actually tried that.
Okay, so let's graph this thing. The second calculate the intersects. And I mean, we could like move the cursor close. I'm just gonna say yes, that's the first graph. Yes, that's the second graph. Sure, close enough. It'll hopefully find that spot right there. Which is what I got. 885.
Okay, I actually did not something to the window. That's all we need, right?
Yeah.
Oh,
I mean,
okay.
we would try to solve it using algebra and say x is 5 or x is 2, but we don't have the ability to.
Yeah.
Okay. Any questions up till now? Okay. Quick summary. I do want to finish the last 2 slides, then I'll give you break time. Okay. But quick summary up till now. You need to be able to graph stuff. Hopefully you have that ability. You also have to be able to solve stuff. So far, you should know how to solve linears, which is basic algebra, quadratics, which involves factoring or quadratic formulas. We don't do cubics and quartics. Guys, can I get better attention than I'm getting here? Okay. So, you need to be able to solve linears and quadratics. Rationals was our first section. Now you should be able to solve exponentials. 2 main ways. You can solve it using like bases, where you try to drop the bases to the same number both times and cancel out the base. Or make 2 graphs cross in your calculator. Truth be told, guys, you need to be able to do both. Okay? I'm going to test you on both, and I'm expecting the diploma will find a way to test you on both as well. So don't just use your calculator. Don't just do algebra. Do a mix of both. Okay? 5 questions in your journal is all I'm asking for. To be honest, 5 is not enough, but like 5 should be the bare minimum for some practice. Okay? Last thought. The curriculum I'm supposed to teach you very specifically says that you're going to have to solve word problems. which is where everybody grows. Because, yeah, it means that you have to now take the skills I taught you and now apply them to solve a problem. Okay. And so I want to show you a couple examples of word problems that are more likely than not that you're going to get a question like. So here's one. Bill put $2,000 in an account and he earns 6% interest per year, compounded monthly. How long will it take Bill to have $3,000? Sounds like a, I don't know. Sounds like a real world kind of question where, okay, yeah, money's going to grow over time.
Can you do the window block?
Well, there is a way for us to solve this. So here's my first question. Do you guys have your formula sheets nearby? I'm curious. Do they still give this formula or something like it on your formula sheets, or did they take that off? Because I don't remember anymore. Let's see. No, it's not. Okay.
Should we write it?
You may want to write it on here. This formula used to be on the math applied formula sheet years ago. Yeah, back before they changed to like -1 and -2, they used to have pure math and math applied. Olden days, you know, makes me sound old. Back when I was young. Okay, you may want to throw this formula on there. This is a formula that applies very specifically to like interest. Okay. Let me help you kind of figure out where certain numbers should go. Okay. A represents how much you're going to have in the future. How much do we want to have in the future according to this question? Well, we want $3,000. So this number down here is going to be $3,000. Okay, then we need to have P. P is called the principal, not Forrester principal, but like in bank terms, principal is the initial amount that you start with. How much is the initial amount you deposit in your bank? $2,000, yeah. Then we need 1 plus I. I is the interest rate per compounding period. Here's the issue. You get 6% per year, but they give you interest once a month. So if you get 6% in a year, how much do you get in a month? Divided by 12, you're right, yeah. If you get 6% in a year, what do you get in a month? 0.5%. Because you got to divide by 12 because there's 12 months in a year. Okay, now that's 0.5%. When you write this I right here, it's got to be 0.005. Because you have to write it in its decimal format, not in its percentage format. And then N is the amount of compounding periods. We're actually going to leave that as N for right now. We might actually change it from N, though, to X. Because usually we're solving for how long will this take. That's what we're solving for. Our question is, what is the length of time it will take? So this is a good example of, I've taught you some skills about how to solve a question. The extra step is, can you take a word problem and turn a word problem into an equation and then solve the equation? This is why kids don't like this, because solving equations is one thing, but you have to then write your own equation and then solve your equation. Does that make sense? But I mean, now that we know how to solve an equation, grab your graphing calculator. We can just graph this thing. There's no reason not to at this point. So I'll make the first line be at 3,000. And then the second one, I just have to be careful with brackets. It is 2,000 bracket 1 plus 0.005. That's my interest rate. All to the power of x.
Just do a constant 3,000.
Yeah, the first one is just straight up 3,000. Times. You should come closer then. It's like 2,000 bracket 1 plus 0.005. Close bracket. Power x. Yeah, okay, so here's the first thing we should talk about is if you just do what Latoya did and just press graph, you're going to see nothing. This is the downside to relying on graphing. It will work, but you have to understand intuitively where your graph is. This number right here is at 3,000. My window currently goes as high as 20. Let me say that again. You need at least $3,000. This graph gets you as high as $20. So let's go up to like say, maybe not 3,000. Maybe I'll go up to like say 3,500. Now when I graph it, hey look, there's that line across the top. And here's a line that is slowly going bigger.
Wait, mine's completely different from yours. What's your
Well, it depends on what your window size is. I'm currently from -10 to 10
Yes.
and -10 to 3,500.
Oh, negative. I'm negative 100.
Okay.
Does that matter?
Well, does the negative on the bottom part of the graph, is that yet necessarily useful to us? Because you're not going to make negative money here. Here's my issue. Currently, my window is set to go as high as x being 10. That would be 10 months. I would love for me to earn $1,000 in 10 months due to just interest, but that seems unlikely. So I'm just going to guess that it's going to take more than 10 months. 81.2 months, Cool says.
I just did the x entry start.
Oh. Okay, why don't I go with 100 months? We'll see whether it crosses.
Mine's just looking crazy now.
So there's the graph way up top here. Here's the exponential graph growing.
Oh,
Oh, I see now. Oh, because I just.
Okay, so it looks like it does eventually cross.
What was your number?
Okay, so my current window size is -10 to 100
Oh, I got
and -10 to 3,500. Guys, it does not matter what your window size is, so long as you can find a way to see where these graphs cross.
Okay, mine was crossing, but it's not.
Okay, so then just do this. Take a leap of faith and try to intersect them and see where they cross. Hopefully you get what I get.
it.
Oh, 81.3. 81.3
That is awful.
months.
So that's
Well, no, it's not that bad. So 81 months divided by 12 months in a year. So just over 6 years for you to earn $1,000 in interest. Keep in mind, that's just money just sitting in a bank. Like that's actually pretty good. Like getting 6.5% interest, 6% interest.
not good.
I mean, I'd love for more than that, but I mean, some banks pay you like 1 or 2% interest. So yeah, I got 6.75 years basically. Okay, yeah, I typed in 81 divided by 12.
Oh, I did it.
You had 81.3, yeah. Okay, any other people I can help troubleshoot before we move on? Did you figure yours out? You're getting 0. You're getting less interest than even your word. Yeah. I got 81.29, I think it was. Okay, can you guys give me 5 more minutes and then we'll take break time? Can you last that long? Okay, let's do one last example, then we'll call her a day. You guys ready? Gina buys a camera 2 years ago. Her accountant told her that starting from the beginning of her second year, she can claim a depreciation rate of 20% per year. Do you guys know what depreciation means? It goes down, yeah. When things depreciate, they lose their value. For example, cars typically lose their value over time unless it's a classic car. Houses usually increase in value over time. So if something depreciates, it's actually losing money. So here's the thing. Gina's camera was worth $2,000. How long until it's only worth $200? So if you use that same sort of formula, where should the number 200 go? Yeah, A, because this is the future value. In the future, it'll be worth 200. P is what it started as. That's your 2,000. Then we need 1 plus I, which is a percentage. But here's the thing, though. We are depreciating by 20%. Good. So rather than 1 plus, we're going down. We need to do, ooh, that's not going to work. 2,000. We need to go 1 minus 0.20. It needs to go down by 20% every year. So now do the exact same thing we just did. start with 200. 200 is what we need to finish with after we started at 2,000. 1 minus 20% because it goes down by 20% every year. And then x is, well, the amount of time. So do the same thing. Again, you have to have some knowledge, though, of what your graph is going to look like. Because you can't just blindly just like press graph because it may not show up very nicely. So like if I just press graph under my old graph settings, you know, I mean, it's enough to work with on mine. I could change the settings around a little bit and try to change it, but I feel like I can see that the graph is going to cross right about there. This graph is actually going downhill, by the way. This is a decreasing graph, which makes sense because the camera loses value. It should decrease in price, right? So,
Can it go negative value?
I don't know that it can go a negative value because think about that whole divorce concept. You lose half your stuff, you lose half your stuff. You don't have negative stuff, you just get closer and closer to zero, right? So try intersecting, see what you get. Hopefully you get what I get here, which is 10.3, it looks like. I think it's a 3. Okay, that's what I have too. 10.31. So that means in 10.3 years, your camera will have started at $2,000 and it'll have lost its value down to $200.
My windows.
You know what? I actually just kept the same window size as last time because it was good enough for me to get a picture of. Okay, quick summary of the day and then a reminder of what our week looks like. So for like what seems like the 4th time today that hopefully you're listening, at least it transfers by osmosis. You need to know how to graph stuff. Hopefully you're good at that. If you need practice, the great news is I gave you a do-it-time with lots of practice in it. You have to do 5 graphs on exponents. That's a pretty low bar here, guys. Please, okay? You also need to know how to solve stuff. Now, I'm not specifically wanting you to solve the linear, quadratic, rational stuff. You need to start working on solving exponential stuff. Don't just solve it with your graphing calculator. It's a good tool. Don't get me wrong. It's a great tool for like these questions. But you need to know how to do some of it by hand too. Also, there's a worksheet on it. Do 5 of those, okay? So give me 5 of each of those by Friday. Tomorrow's a work day, as well as our last half hour today. I'd really recommend don't leave today, because you've got 2 hours. Start on that assignment, okay? Try to do the assignment before, well, half an hour today, an hour and a half tomorrow. So try to do the assignment before our quiz on Thursday, right? Because that's how you get better, right? Do the assignment first, then do the quiz Thursday. Friday is Flex Friday. If you are behind on stuff, please, I'm begging you. I'm like literally, no, not literally. I'm on my knees here, guys. Get caught up, okay? It's not just for my sake, it's for your sake. Because otherwise you're going to drown. You'll never get caught up in this course. So use that Flex Friday to get caught up. Sound good? So the next day and a half is work time. Thursday's the quiz. Take a break. No, your assignment's due Friday. But I think it's best if you can try to finish it before the quiz, right?